How do you select an amplifier to match your speakers? This question comes from someone who has a wonderful name, Paul, in London, England. I'm in the process of building my own speaker driver entirely. 3D printing the cone, the chassis, the spider, and the surround. Wow, that is impressive, Paul. My question is, how do you determine what amplifier will work best with a specific driver? I've found that in the past, older amplifiers and tube amplifiers sound better on older, higher inductance drivers, and newer amplifiers work well with more current, lower inductance drivers. Is this due to the damping factor of the amplifier? Yeah, actually, I think if you've had that observation, that would likely have explained it. In my experience, the older amplifiers, let's go back way to the 50s and late 40s and 50s, right? Back then, of course, it was all vacuum tubes. Everything had very high impedance because you've got, transformers that are coupling everything. That I don't even think we had a damping factor rating back then, because speakers were by necessity really easy to drive. They had to be, because all the amps were weenies. You had a 20 watt amp. Boy, a 50 watt amp was kind of a big deal. And everything had to work with fairly high efficiency speakers because the amplifiers just, weren't up to the task. As time went on, solid state amplifiers came along, higher power vacuum tube amplifiers came along, and output impedances went down, which means damping factor. And damping factor, by the way, just if you're curious, damping factor is a rating that we use that is essentially telling you what the output impedance of an amplifier is. But what it means and why we care about that is that the lower or the higher the damping factor, the lower the output impedance, the higher the damping factor, the better ability the amplifier has to control the loudspeaker. Because loudspeakers can be what we call inductive. In other words, they have coils of wire, and when you energize a coil, it creates a magnetic field, but when that magnetic field collapses, it shoots back an electrical energy into the amplifier. So you've got this kind of push-pull kind of thing, and an amplifier has to be able to ignore that reverse, the electromotive force that comes back into the amplifier. So that's where damping factor is really kind of important, depending on the kind of drivers and the kind of crossover and all that you use. So I would have to suggest to you that if I was designing a new speaker, and I'm very impressed that you are 3D printing everything, that's really cool. Send us a picture when you get it done. Seriously, that's awesome, Paul. If I were in your shoes, I would certainly choose a solid state amplifier. Now, my favorite is vacuum tubes on the input, solid state on the output, and there aren't that many around. Our BHK series has that, but not that many around. So pick something really good, and you gotta match amplifiers to the characteristic sound quality that your speaker is going to produce. So if your speaker winds up being a analytical, kind of bright, sterile sound, you're going to want an amplifier that is fat, warm, and juicy sounding. If you have a speaker that is fat, warm, and juicy sounding, then you want to have a fairly lean amplifier. So thank goodness all amplifiers don't sound the same. That's a good thing. So you can choose which one has the synergy that you want. But your safest bet is to go with solid state outputs. So get the synergy you want by figuring out what kind of sound you're looking for when you voice that loudspeaker, and I think you'll be in pretty good shape. Good luck with your project, Paul. I think it's awesome. And do send us some photos, just paul@psaudio.com. If you're in the neighborhood, come visit us. We are always welcoming of guests. We have guests from all over the world. pretty much daily now. People just show up and say, Paul said to come. Here I am. So good. Come on down. We love it when you come. All right. Talk to you tomorrow.